Our next presenter from Thomas will talk about the comparison of machine learning algorithm for medical data.
Yes. Hello everyone, my name is Ali Sharif. I'm a master's student at Sharm University of Technology. I'm currently specializing in the field of algorithms, and I'm sincerely thankful for this opportunity.
Hello everyone, my name is Alex Helmersson. I'm an embedded system designer, and I'm also very thankful for participating here today.
So I'll start off by describing carotid endarterectomy. It is a surgical procedure in which the doctors clamp the carotid artery in order to remove some plaque, which is blocking the blood flow to the brain. And as they do so, they have to reroute the blood flow temporarily, which can lead to insufficient blood flow to the brain, hence the stroke can occur. So in order to prevent this, it is very crucial to monitor all the signals from a patient who's undergoing this surgery right now. And there are specifically 3 critical events, which you can see in the picture above. It is 5 minutes before the clamping, 5 minutes during the clamping of the artery, and 5 minutes after they release the clamp. So in order to enhance the monitorings, we have, together with a hospital in Northern Europe, specifically in Sweden, they're the largest hospital, we have made a system for algorithmic comparisons of patient signals in a real-time environment. So in our system, a patient who's undergoing the surgery right now can be compared to the patient who previously received a stroke during the same surgical procedure. So this can be very helpful for the doctors, as they can avoid complications which occurred in the past, as well as they can revise the strategies accordingly. And if needed, they can terminate the process of clamping. So how did we achieve this? So we have developed a web application which we call StrokeSex. We have a complete pipeline from the extraction of data to visualizing it. So from this monitor you see in this picture, we continuously extract data points. They enter our backend where we do the algorithmic comparisons, and then we display interactive graphs at the front end together with the similarity score. And we have also implemented a database in MongoDB where we can store the previous stroke patients as well as new monitoring sessions, which we can leverage from for future comparisons. So now more about the algorithms. Alex.
Yes, so in the project we utilized 3 different algorithms. They were SIMSAX, dynamic time warping, and Pearson's correlation coefficient. SIMSAX works by dividing each series into windows and then representing them as sequences of letters. If SIMSAX finds the sequence in both series, it will mark the indexes, and the final result will be the percentages of indexes that have been marked in the series. Dynamic time warping works by comparing the y-axis distance between indexes of each series, and the final result would be the shortest possible distance between these indexes. It also has a kind of a catch, but we'll talk about it later. And Pearson's correlation is the covariance between 2 series divided by the standard deviation of each series. It was our baseline for the project. Notable was that we used these algorithms on each signals, so we tried to find a general algorithm for all signals instead of specifically for specific signals. And for some results, yes, you can see here for patient pair A and patient pair B, you can see the signals as well as the physician's rating of how similar they think the signal were. You can see the scores of SIMSAX and DTV that range from 0 to 1, as well as the score of Pearson's correlation coefficient from -1 to 1. Looking at these numbers, you see that for patient pair A, they somewhat correlate SIMSAX and DTV with the physician's rating, but they are more inconsistent for patient pair B. And this inconsistency is also what we found in our work, unfortunately. But however, there were some aspects that showed great potential. For example, comparing short period of live data with symbolic representation of sequences that had ended in bad incidents, as well as the physicians wanted to look more into dynamic time warping for specific signals. Now Ali will show you some of our GUI.
So this is our graphical user interface, and the core idea is a method for early stroke detection. So at the left side you see the previous stroke patients. At the right side you can see the corresponding signals. So you can select multiple signals, and then these signals are in a live environment compared to a patient who's undergoing the surgical procedure of carotid endarterectomy. And you can interact with the graphs. You can also see the similarity score here. And we have also implemented a what we call total similarity score functionality, in which you can select a group of signals that are common amongst both of the patients, and you can also weight the signals depending on the relevance and importance of them, which can be done in accordance with the physicians, and according to the preferences you can do a tailored weighting of the signals. So yes, this was a brief demo of our application, and we can show you more at the poster session. And now on to the impact of this project.
Yes, so by completing the pipeline and implementing this, we have shown that it is possible to implement this kind of system in an operating room environment. We are also, by analyzing the algorithms and discussing signal patterns and characteristics with the physicians at Sahlgrenska, proven the feasibility of this kind of system. We have also contributed to a much larger ongoing project at Sahlgrenska regarding machine learning systems in real-time operating room environments. And for future work, it would be of interest to investigate more into a specifically tailored algorithm to specific signals. And also hopefully one day implement a real machine learning system in a real operating room environment.
So this is a picture of our bachelor thesis group together with, we were joined with Helena and her team of researchers and doctors, and when we discussed with them, this type of system is needed for them, and it helps them to build situational awareness. And today, unfortunately, our group couldn't join us here. They would love to be here, but on behalf of them, me and Alice wants to thank you all for listening, and hereby we open up for questions.
Thank you very much. Are there questions from the audience?
Just can you explain a little bit more the context of how your software is used? I would like to understand it better. Is it after an operation, to prepare for an operation, or what moment am I using this tool?
Yes, so it is used during operation, but of course it wasn't feasible enough, so it was more of a proof of concept in this job. But it's during the operation of a CEA procedure. Yeah, that's the.
You have mentioned that you have shown that there is some potential of using this kind of predictors to predict a stroke during surgery. What's the accuracy that you achieve? So the maximum that you could achieve, and what's the combination of tools that you can use to make this assessment?
Yeah, so the medical data will not include for specifically who got the stroke or who didn't, but it was more about if it didn't look good or if it looks good. If you go back to the tables, let's see here. We can see that in some cases they do somewhat good, or they are somewhat good at estimating similarities between. So the project is more about basing similarities on earlier patients than estimating or if it's a stroke or not. And so with the comparison, we got somewhat good result, but not good enough. Am I clear or no?
Yeah, somehow. Yes.
And in the consultation with the physicians, we showed them graphs of the patients, and we didn't tell them anything about their medical data first. So they said, okay, we think they're equal or not, and then we showed our result from our algorithm, and we did some few iterations.
Thank you. Any other questions? Yes, please.
Have you considered using sequence-based machine learning models which have been very popular and effective in the last few years, such as transformers or recurrent neural networks to do this?
So we were part of a larger project, and the physicians wanted to test if this is possible in a real-time environment. And now when we've showed them that this is possible in a real-time environment, the next step can be to use such machine learning models that you mentioned.
Yeah. They also wanted to analyze comparison algorithms as inputs to their machine learning algorithms. And so that's kind of
I have a very follow-up question. Why you have selected these three models? Why not something else?
SAX is a pretty known algorithm, and SimSAX was one of our colleagues who did a paper on that, and so we decided to use that one for dynamic analysis of the series, as well as DTV is also very dynamic, so it can handle like medical data much better than statical algorithms, if that makes sense. And Pearson's is more static, so we use that as a baseline for the other. Yeah.
Thank you very much.
Thank you.
So, our last presenter of this session will talk about what data science care to recall. It's an interesting topic. And the stage is yours.
Yeah, thank you very much. I hope everybody can hear